Assalamu alaikum. Basic concepts of vectors. Let's start with the physical quantities. Physical quantities. All measurable quantities are called physical quantities. Physical quantities are classified into basic physical quantities, and derived physical quantities. Further, basic and derived physical quantities are further classified into vectors and scalars. Let's define scalars first. Scalars are the physical quantities which can completely define by their magnitude only. Whereas, for example, mass and time. Um, Now, vectors are the physical quantities which completely define by their magnitude and their direction. For example, displacement. Velocity, acceleration, etc. Now, our major concern is vector, and let's start with the representation of the vector. Representation of vectors. Symbolic representation, and graphical representation. Symbolic representation. Symbolically, a vector is usually in many books is represented with the bold letter. For example, A, we will bold it like that, and another notation that is usually used is a letter with arrowhead. Letter with arrow head. For example, this. Now, graphical representation. Graphically, a vector is represented with an arrow, where the arrowhead of the vector is indicate the direction, whereas the length of the vector, according to some scale that we choose ourselves, is represent the magnitude of the vector. That is how vector is usually represented, symbolically or graphically. Now let's start with the classification of vector. Further, we classify the vector into unit vector, which defined as a vector used to indicate the direction and has magnitude equal to 1. Mathematically, it defined as it is usually represented with the cap sign and vector divided by its magnitude. We'll define magnitude later. Now, normal unit vector. The second type of vector, normal unit vector. Same definition, just little difference. A vector whose magnitude is equal to 1 is equal to 1 and it normal to the surface. Consider as shown in the figure. Let's consider a surface, then a unit vector is like that. Next is null vector. A vector whose magnitude is equal to 0 and has arbitrary direction. It is usually represented with a dot sign, has arbitrary direction, 0 magnitude. Next is equal vector. Suppose we have two vectors, vector A and vector B. They are called equal vector if they have same direction and same magnitude. suppose two vectors A and B, they are equal if magnitude of A is equal to magnitude of B and direction of A is same as of vector of B. Now parallel vector. Two vectors, suppose two vectors, vector A and vector B, are said to be parallel if they have same direction. Like suppose A is a vector and B is parallel if it has same direction. There is no condition of magnitude. Magnitude may be same or may be different. Now antiparallel vector. Suppose again A and 2 B are two vectors. They are said to be antiparallel if they have opposite direction. Opposite direction. Like suppose this is A vector and this is B vector. They have opposite direction, so they are called antiparallel of each other. Another type of vector is position vector. But before I define position vector, I would like to discuss something about rectangular components and Cartesian coordinate system. Suppose two lines, one is a vertical line and the other one is horizontal line. Horizontal line in Cartesian coordinate system is marked as x-axis, whereas the vertical line in Cartesian system marked as y-axis. The unit vector along x-axis is usually represented by I with the cap sign, and the unit vector along the y-axis is usually represented by the J's unit vector in many books. Suppose a point P having components A and B. Suppose that is the point. Then a vector which used to locate this point is from the origin can be represented as, suppose O is the origin, then OP is the vector whose magnitude is OP. Length of the vector is OP, and the direction of the vector usually represented with the angle that the vector OP is made with the reference axis. Consider the reference axis as x-axis, then the theta that it made with x-axis anti-clockwise is indicate the direction of the vector. The vector OP means if we move A units along x-axis and B units along y-axis at an angle theta, then we will reach that point. That is how we deal with vector in Cartesian coordinate system. Now the another thing that I that I want to discuss with you is the rectangular components of the vector. Rectangular components, sp- suppose a vector, suppose a Cartesian coordinate system, two-dimensional Cartesian coordinate system. Mm, a vector, suppose a vector A making an angle theta with x-axis in order to find the rectangular components of the vector. As we know that I is the unit vector along the x-axis and the j is the unit vector along the y-axis. In order to get the components of the vector, we will draw the perpendicular on x-axis and perpendicular on y-axis. According to some basic trigonometric rules, as we know that sine theta is equal to perpendicular over hypotenuse. It is an angle of 90. So perpendicular is, suppose the x component of the vector, y component of the vector is ay and the x component of the vector is ax. So the perpendicular is ay and the hypotenuse is a here a is the magnitude of the vector. The direction is represented with theta. So sine theta is equal to this. This implies that okay, uh, ay is equal to a of sine theta. That is the vertical component or y component of the vector A. Also we know that cos theta is equal to base over hypotenuse, as base is equal to ax in the figure, and you can see it is the base, uh, and the hypotenuse a though, so this implies that ax is equal to a cos theta. So it is a horizontal component or x component of the vector. So now again see the figure again. Let's consider the figure again. Here it is the y component of the vector, which is shown in the vector figure, and it is the x component of the vector. As we as according to the head to tail rule, uh, vector A should be equal to vector A should be equal to xi component and a yj vertical component and horizontal component. You can see from the figure, here is the one vector and the ay is the second vector. The direction of the x-axis is represented with the I unit vector, whereas the direction of the vertical component is represented with the j unit vector. So as unit vector is defined as vector divided by its magnitude. If you remember, as we discuss later, a few minutes later, here a is a vector, and so the magnitude should be this vector a, so that will be give us ax vector is equal to ax of I. Similarly for y component, y unit vector. So here we have a vector into its rectangular components. In this case we find out the vector from its in this case we find out rectangular components of the vector, and we can also calculate vector from its rectangular component. For example, we have components of a vector, then we can calculate a vector from its component if the components are given. For example, let's consider a vector whose components are given, um, like vector x component, y components are given. Same, consider the same figure. Then according to as we know that a vector is defined by its magnitude and direction. So if somehow we are able to calculate this magnitude and direction, it means we completely define a vector. uh, so let's start with the same diagram. Consider x-axis, and it is a vector a, for example, and its rectangular components are given. It is a y component and it is a x component, where it is x-axis and it is y-axis, and it is a theta angle that it is made with the horizontal axis. So if as we know that according to Pythagoras theorem, hypotenuse square is equal to perpendicular square plus base square. Here the hypotenuse is a and perpendicular is ay and base is ax. So if we take square root on both sides, then a should be equal to, rearranging it, a, that is the magnitude of a. Now direction, as we know that tangent theta is equal to perpendicular over base. Here the perpendicular is ay and the base is ax. So theta is equal to tangent inverse ay of ax. As theta is giving the information about the direction of the vector and a is the magnitude of the vector, so the way to calculate the magnitude of the vector and the direction of the vector, hence a complete vector can be defined by these two information. Now we will define position vector. A position vector uh, is defined position vector is defined as a vector which used to locate uh, locate position of a point from the origin. Consider this figure. Here P is a point on xy plane, and OP is a position vector which is used to locate the position of the point P. This graph, this vector means that if we move A units along x-axis and B units along y-axis at an angle of theta, so we will reach the point P. So the position vector giving us the information about the point. That's we all have for this lecture. Thank you for listening me.